Hi class, there's one last topic we want to talk about in this chapter, and that is how the planets move around the sky. And when people thought, when people started coming up with the correct explanation as to why they move this way. So the ancient Greeks kind of had the right idea, but they rejected it because they couldn't see a certain phenomenon. We'll talk about what that is. So what do the planets actually do as they move? In particular, what does the planet Mars do? Well, Mars is one of the 5 bright planets we can see with the naked eye, and these are all planets the Greeks could see, the ancients could see these planets. They didn't really know what they were, but they were bright objects that moved differently through the sky than the stars. All the stars traveled, or rose in the east, set in the west, just traveled across the sky in the same way every day. And but these planets moved relative to those stars. And usually the planets moved in an easterly direction from night to night. So if you were to look at a planet, say Mars, right here where it is, and this direction to the left is east, then the next day Mars would be slightly to the left of where it is now. And the next day it would be slightly to the left of where it was the day before, and so on. And over the course of several days and months, the stars, or the planets, would be moving relative to the stars slightly to the east. So they could measure that very carefully, but they noticed something strange eventually. So here's Mars traveling along to the east day by day. So here's November 3rd of 2011, and these aren't every day, but these are, over a few days, we can plot the position of Mars. And Mars moves to the east, but then there's a period of time when Mars actually backtracks. So on January 23rd, 2012, Mars was right there, but then in March of 2012, Mars actually starts moving back the other way, in the westerly direction, relative to the stars. And it continues to move backwards in the westerly direction, and then stops again around April 11th, and then turns around and starts to go back to the east again. This is called retrograde motion, or apparent retrograde motion. It appears as if Mars is stopping and turning around. Retro means kind of like to go backwards. So apparent retrograde motion. And the ancients tried to explain it, and they thought, well, perhaps this is because the Earth is moving and Mars is moving, and it's a matter of perspective. Well, that's the correct explanation, actually, as we'll see, but they couldn't detect something called parallax. So we explain this by saying that the Earth goes around the sun and Mars goes around the sun, and because we're closer to the sun, we sort of overtake Mars in its orbit, and during that sort of overtaking period, it appears to us as if Mars is going backwards, and we'll see a little video that explains that. But the ancient Greeks thought about this idea, and they rejected it because of one thing that they couldn't actually observe, and that's something called parallax. So if the Earth did go around the sun, and you looked out at the stars, there's going to be some stars that are farther away, and really far away, and possibly there'll be a planet or some other star perhaps maybe closer. And if that was the case, you would see that object that's closer in different positions among those distant objects because of our perspective. So in other words, if we're over here in January to the right of the sun, when we look at that closer object, we're looking in this direction, and we see these stars over here right in the vicinity of this object. This is the picture we would see. This is it over here. This is January over here. So we see these couple stars with that object kind of right in between these two, right there. And then as Earth moves around into July, we are looking in kind of a different direction toward that same object, but we're looking in a different direction toward these distant stars, and we see that that closer object has moved relative to those distant stars because of our orbit around the sun. Well, they didn't detect this for any stars. They didn't detect this parallax for stars. Yeah, they of course, planets move differently, but if they looked at anything else but those 5 wandering objects, the planets, they didn't detect any parallax. All the stars in the sky appeared to always be in the same configuration, the same setup. There didn't seem to be any changes whatsoever. So that led them to believe that the Earth did not move, and that everything went around the Earth. And so if the Earth did not move, then that correct explanation of the Earth overtaking Mars' orbit to cause Mars to appear to move backwards can't be valid. Earth has to be orbiting around the sun for that to be the correct explanation. So ancients could not see parallax, and therefore they said that the Earth doesn't move, and they had to come up with a different way of explaining this retrograde motion, this apparent retrograde motion. So the next chapter discusses several of those models that people came up with to try to say that the Earth was not moving at all, but everything else was moving around the Earth, and yet there's this kind of complicated motion that the planets show, this apparent retrograde motion. They had to explain it in an interesting way. And the explanations, were interesting. They weren't bad, but they weren't perfect. And they still led to errors in predicting the future positions of planets. So eventually, we came up with the correct explanation that the Sun is the center of the solar system, and the Earth does move around the Sun. So let's look at this little video. This is a video from the study area in Master in Astronomy, and it's an interactive figure. And I'll just play it. There's a person talking, so we'll just let them speak, and we can listen and watch.
This animation will show why we observe apparent retrograde motion for Mars. The lower window will show the orbits of Earth and Mars, with the names of the zodiac constellations that we see in the distance at each point. The upper window will show our view from Earth, in which Mars appears to move among those zodiac constellations. As you watch, keep in mind that the animation is simulating a full year each time you see Earth orbit the Sun. In other words, the changes you see in the view from Earth are something you would notice only if you marked Mars's position in the sky night after night for many months. On a single night, Mars rises in the east and sets in the west, just like all other celestial objects. We start by watching a few months of simulated motion in which we see both Mars and the Sun moving eastward relative to the stars in our sky. As we pause, notice that while the animation showed the Sun passing directly in front of Mars, in reality, Mars would generally be slightly above or below the Sun in our sky, and would be hidden from view at that time because it would be obscured by daylight. We now resume the animation. Although it is going fast, you should notice the following key points. In the upper window, you can see that while Mars usually moves eastward relative to the stars, there are times during which it appears to turn around and go backward, or westward. The word retrograde means backward, so those periods represent what we call apparent retrograde motion. In the lower window, of course, you'll see that both Earth and Mars always orbit the Sun in the same direction, with Earth orbiting faster. If you watch closely, or stop and start the video, you'll see that the periods of apparent retrograde motion occur as Earth passes by Mars in its orbit, which happens about once every 2 years.
So there Mars goes backwards right now, and then it goes forward again. So it's a very small motion, and you had to watch Mars very carefully to be able to see this. But it should be clear that Mars does this sort of forward motion, and then a little bit backward, and then forward again, this retrograde motion, because the Earth is overtaking it in its orbit. So hopefully this helps explain some of the things we see in the sky, and it leads into the next discussion of the ancient models of the universe, the solar system, and how we ultimately came up with the model of the solar system that we have today.